Next we have is temporal difference algorithm. Okay, so in this algorithm we call it, also with the name TD, like temporal difference algorithm in short form TD. So it is a concept in reinforcement learning that refers to difference between the predicted value of a state, or you can say state value pair, and the actual value that is received from the environment. Okay, so in the other word, it is a error term that occurs when we try to estimate the value of state based on our current knowledge. So Q learning SARSA are like a temporal difference learning algorithm. So the temporal difference error is used to update the estimated value of current state. Okay, so by continuously updating these value estimate based on the observed temporal difference error. Okay, so the agent is then able to learn or make decision better and achieve better reward in the environment. So it is not a error, basically it is a type of reinforcement learning used to estimate the you know um value function of MDPs, which is basically a mathematical framework for modeling decision making in situation where outcome are partly random and partly under control of decision maker. So the temporal difference algorithm basically work by updating the estimated value function of a state based on difference between the reward received after taking an action and the expected value of next state. So the difference is called the TD error, and it is used to update the estimate of value function for the current state. Okay, so this type of learning, or you can say temporal difference learning, basically combine the advantage of both Monte Carlo and the dynamic programming method. Like we have seen in Monte Carlo method, it learned from complete episode of experience and does not require a model of the environment. Okay, like dynamic programming method, it basically update the value function based on estimated value of future state and does not require waiting until the end of episode or to update the value function. So overall, the temporal difference learning is a powerful and widely used reinforcement learning algorithm, and it is often used in combination with other algorithms such as Q learning, SARSA, as well as deep reinforcement learning. Okay, so how it works basically. Okay, so basically first what we do, we initialize the value function for each state to some arbitrary value, or you can say 0, and then we observe the current state of the environment. Okay, and we take action according to current policy and observe the resulting reward and next state. Then then we update the value function for the current state by taking the sum of current estimated value and the difference between the observed reward and the estimated value of the next state, that is temporal difference error. Okay, and then we update the policy by selecting the action with the highest value in the current state, and we repeat the step until convergence, so that is the value function and the policy no longer change. Now what is the difference between, I mean, Monte Carlo and Q learning that we have learned till now? So the main difference between temporal difference learning and other reinforcement learning like Monte Carlo and Q learning is that temporal difference learning update the value function at each or you can say every time step, rather than waiting until the end of episode like we do in Monte Carlo, or separate target network like Q learning. Okay, so this allow temporal difference learning to learn in the real time, okay, environment where reward may be delayed or uncertain. Okay, so also we can say the Monte Carlo uses experience gained from the complete episode to estimate value function of a state, and it does not require the model of the environment and work well with the episodic task where the agent interact with the environment until the terminal state is reached. In temporal difference, update the value function of state using the difference between estimated value of the current state and the estimated value of the next state, so it can learn online and incrementally, making it suitable for you can say continuous task, where the agent interact with the environment over multiple time steps. Now in dynamic programming, it uses a model of environment to compute the optimal policy and the value function, okay, and it require complete knowledge of the environment and is suitable for problem with a small state space, okay. And q learning, obviously it is a model free algorithm and of policy algorithm that learn an action value function through trial and error. So it updates the value of a state action pair based on the maximum expected future reward, and it can learn from incomplete and noisy information and it is suitable for large state space. So in summary, the main difference between these approaches are their basically their requirement for the model of environment, and I mean the way they update the value function and the suitability of different type of task and the state space. So that was all about temporal difference and difference between other algorithm. Let's implement it using Python to see how the implementation different from other algorithms, okay.